Hi, my name is Kimoni Nanya, and this is my lab 3, which is about the magnetic field of dipole magnets. So the introduction is the Biot-Savart law is an equation that describes the magnetic field generated by a constant electric current. In this lab, the magnetic field was generated by a small bar magnet. This field generates a magnetic dipole moment on surrounding objects. And the purpose of this lab is to determine whether the magnetic field generated by a small bar magnet is distance dependent. And the results showed that the magnetic field is distance dependent, and the distance is 0.228 meters. And the B calculation, which is the magnetic field, is 1.9612. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field, which is B, as you see earlier, increases. So these are the models and principles that we use in this lab, like the Biot-Savart law, which that's the formula, and the formula for the magnetic dipole and the magnetic loop, and also the formula to calculate the magnetic field at any location. So the experiment, the system was my phone using the Magnetometer app. The surroundings is the magnetic field generated by a small bar magnet. The initial conditions include the observation point at the top right corner of the magnetometer, which was created by the two tapes, as you can see on the right. And the bar magnet generates a magnetic field. That's the initial condition. And in the experiment, basically, we just use the magnetometer app to generate axis of the field created by the bar magnet. And assumptions used in the experiment include the magnetic field of Earth is taken into the account. The phone is pointing in the north direction in terms of the magnetic field of Earth, and no other electric fields should be in the surroundings. So this is my code. Basically, I added in the constant, the u over 4 pi, and to calculate the magnetic field, I went ahead and used the dipole calculation, basically using the magnitude of r, generating r hat, and then using the u over 4 pi formula to generate the B, which is the magnetic field. And on the right, to draw the 4 arrows to represent the magnetic field perpendicular to the axis, I went ahead and did that 4 times, r perp 1, perp 2, perp 3, perp 4, etc. Basically just doing the same thing over, just changing the numbers, basically. And for the discussion, so my result was that the B at 45 degrees at the distance is negative 1.9 times 10 to the negative 5. However, the data calculation for my B was 5.309 times 10 to the negative 5. So my data is very different. The computational model is much smaller than the data, and this is by an extreme factor, meaning the electric field calculated in the computational model is smaller than what my data collected. So possible sources of error include magnetic electric fields in the environment that I did not account for. Moving my phone along the axis may have shifted the direction, and rounding error. And at the bottom, you can see the chart generated by the relationship between the distance and the magnetic field. So in conclusion, as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. And to answer the what if questions, the z component will be unaffected. However, because of an orientation shift, the x and y components will change. The magnetic field, which is Bx, will also change due to Earth's magnetic field now affecting the results because the orientation has changed. And for the second what if question, the measurements will be proportional by a certain amount. These will have a higher scale, and the results would reflect as if a stronger magnet was used. Thank you.